Welcome to Ask the Educator, a podcast brought to you by Healthmark Industries. Are you a sterile processing technician or manager? Maybe you work in infection prevention or biomedical engineering. Whether you're a frontline tech, endoscopy tech, OR nurse, or surgical services administrator, you undoubtedly have influence in medical device processing at your facility. In each episode, we speak with experts from the Healthmark Clinical Affairs team, industry leaders, or special guests from the trenches to answer your questions and bring you relevant industry information, equipping you for excellence in medical device processing. My name is Kevin Anderson, and I will be your host. Now let's get started. Hello, everyone. This is Kevin Anderson, your host for the Ask the Educator podcast. I also have with me our co-host, Adam Okada, and as our guest of honor, Healthmark's very own Jahan Azizi. Jahan, welcome to the show, man.
Thank you. Thanks, Kevin. Thanks, Adam.
So for this one, Jahan, we were bringing you in because we're going to be talking about conductivity issues. The real issue ends up happening in the operating room, unfortunately, but this is very relevant to the sterile processing industry because this conductivity issue of bipolar or monopolar cautery cords kind of falls in our lap a little bit in sterile processing, and we're going to kind of address that as we go. But how would you like to kind of maybe introduce this topic and to the audience? Like, what are the issues surrounding these bipolar and monopolar cords when we talk about conductivity?
Sure. As you know, in order to attach the surgical instrument to the machine, you use obviously a cord, either for bipolar procedures or for monopolar procedure. We have talked about insulation testing of these, which has been happening a lot more than that. But the conductivity, which is the wire that attaches the connector to the machine or to the instruments, really haven't been taking that much attention for the past several years. And I know being part of the risk management, working with the operating room, there were issues with that. There were patient burned. There were indeed surgical fires, operating room fire that happened. And when we did the investigation, we found out that, first of all, these cords are not forever cords. So most of them have a specific shelf life, like most of them 20 to 25 use or reprocessing. But what happens is that when you use them, even during that 25 times, that since you're pulling on the cord, and as you know, with the monopolar cord, you have the end of the machine is really heavy. So that kind of going to add more pressure to those conductors inside the wire. And then over time, they break. Say, for example, we have 100 conductors in a cord, and then over time, say 80 of them breaks. Those 20 probably is going to work, give you energy. But if you don't have adequate energy, the surgeon, for example, said that increase the energy by X amount. Now you have a lot more energy coming through, but not enough wires, not enough strand of wire to carry that energy to the instrument. Therefore, you get in that group a big zap coming out, smoke, and catching the fire either at most of the time at the instrument side, at the equipment side. That usually that happens and causes the surgical fire or burn, obviously, if it's near the patient. So there is an issue with that, being able to make sure that the conductivity of those cords are intact.
Yeah, and that should get people's attention right away. If we're talking about surgical fires and burns to the patient, I mean, these are serious things that sterile processing really needs to care about. And typically, when we talk about insulation testing or anything like that, most people think laparoscopics. Oh, yeah, I test my laparoscopics for insulation. That's not the only thing you should be testing. If we look at that amendment 2 from ST79, it does say cords. And not only the insulation testing cords, but conductivity. We need to make sure the cords are actually working the way they're supposed to work. So, Jahan, can you give us some examples of things that have happened from damaged cords and things like that?
Sure. Yeah. If you the best source is that is looking at the FDA manufacturer and user facility experience, or MOD database. In that one, actually, I usually see that the tip of the iceberg. We can see that in that if you search for surgical fire or cord, you come up with, I just did one today, and at least I had five examples that I can bring up. For example, one of them, they said a monopolar cord that obviously had additional complaint in the past. A fire started while the surgeon was using it. The hook was attached to the monopolar cord. The cord frayed near the plastic end, came off, fell into the pocket of the drapes, and started the fire. So this is one example. Another one is that this one actually I kind of witnessed that. He said that the surgeon requested that the Bowie or the ES2 be turned to 40 watts. That means obviously he wasn't getting at the 20 watt or 25 watt. So what he was hoping maybe it wasn't enough energy. But this is that case that I mentioned, that enough energy is not going through because you don't have enough conductors on that. At this point, when they increased that to 40, the Bowie had completely separated from the remainder of the cord and fell into the operating procedure. So this is another example of that. Some of those strands of wires are breaking, but there are few of them intact. When you increase the energy from 25 to 40 watts, now you're going to see that blip coming up. Another one is that a surgeon was using a Bowie monopolar instrument that was attached to a Bowie machine with a cable. During the case, the tip end of the cord was attached to the Bowie machine, sparked, and the cord broke in two pieces. The second cord was open, obviously, during the procedure and finished the procedure. So if you look at the MOD database, you see a lot of examples of these that either near misses or somebody caught the issue and moved forward. So that's really, as I said, those are the tip of the iceberg. And if you look a little more, if you talk to the operating room staff, you're going to see that there were some issues that near misses, they caught it before something happened, or sometimes they got dust the fire and move on with the procedure. And unfortunately, after the case, that becomes history, and they don't report them. But there are few reports in FDA MOD database that people can look and find out, see what's going on.
Yeah, I'm glad that you mentioned that the MOD database is kind of like the tip of the iceberg. And if people aren't reporting things or you find reports of things in the MOD database, you can guarantee basically that is a very small percentage of what's going on in the real world. All I can tell you is that I've actually lived through one of these. I was working in the operating room during a very routine gallbladder removal surgery, and working with a physician that I work with all the time. And we do a lot of gallbladder removal procedures. And I still remember to this day, the lights are off and all of a sudden a huge spark takes place right near the surgeon and the entire cord just severed in half. And it was very scary, to be honest. And the fact that he was able to kind of keep his composure and everyone in the room was able to keep their composure and check for fire and check for injury and all of that was very good. But it was a major near miss. And to find out later on, that these cords have limited lifespans and all of this stuff, and that, all of this stuff is known, but not necessarily known by sterile processing professionals that can actually do something about it. Jahan, the next question really is, Adam talked about the standards and how they've been updated to explain that there is a need that we look at these cords and inspect them for damage. It's unfortunate, but the standard has been updated, but it's only after all of these reports and after all of these occurrences, if it happened. But what I think it's really important that people understand is, what does the manufacturer's IFU say about testing these cords? Because I have a feeling that these IFUs have probably been around a little bit longer than the standards have been updated, correct? So, as a sterile processing professional, we probably should have known about this, before these reports came out. So what does the IFUs say about testing these cords?
It was interesting. So when I was looking at some of the IFU, I purchased some brand new cord to see what is inside them. And it was this kind of a booklet that you really needed magnifying glass to read it. It was like in 27 different languages in a small, really font. So if you magnify that IFU, all of the reusable cords. So if you have a disposable, obviously that's a different issue. One-time use, you pitch it. But all of the reusable cord, first of all, they have how many times you can use them, mostly 20 or 25 times. So that's the first thing that you need to identify these cords per manufacturer recommendation that you test them, pitch them, or you throw them away after like 25 use. So that's the first thing. Do you have a system that keeps track of those? Second of all, in addition to that, for example, Curvin or Askilab, it says that after and before each use, you must test the continuity. And in particular, I said that you need to use a ohm meter to use the continuity of these cords after and before, which is kind of interesting that how can you test it in the operator? That would be before you use. But in the IFU indicates that you must test these after each processing or use. At least the reusable cords. Disposable, obviously, hopefully manufacturer did that quality control, and when you receive it, it's been tested. But yes, you must test them, but manufacturer recommend, and you're correct. So we have the standards, we have the issues with FDA, but at the end of the day, when something happens, manufacturer's IFU trumps everything else. So that's the important part that people need to take consideration when you're looking at any devices.
One of the things you're talking about, like with the uses and all of these things that are in the IFUs, it's so interesting. And it's one of those things we don't really think about, because we do think about, again, like insulation testing and that kind of stuff. But the uses is a huge one that we don't have a great way of tracking those things. So that's a great point that you brought up. And then can you talk a little about the test equipment? How do we actually, so let's say, okay, we take this seriously. We're going to try to start testing our cords and cables to make sure there's conductivity in them. What kind of test equipment do we have available that can do that?
So for biomed tech, obviously, every biomed technology or HTM technology, they have a ohm meter, voltmeter at their possessions. But obviously, those are the one that you want to make sure that you have adequate cords, adequate procedure, and then is it 0 or 0.4 or what have you. So we found out that if biomed was responsible for these cords, they would test them obviously using the ohm meter, and that's the manufacturer recommendation. But we found out at Healthmark that obviously people are not testing them. I haven't seen too many ohm meter in SPD department, but for request of some of our customers, we designed this continuity tester. Basically is a green for good and no green that the cord needs to be take a look at or send back to the manufacturer or pitch or give it to biomed for additional investigation. And really that's one thing that I'm hoping that SPD department can use this simple device by just plugging the monopolar cord and the instruments in it. And then you test actually not just the cord, you check the continuity of the instrument as well. So is basically a tester that we developed at Healthmark to make life easier for our SPD department.
That's excellent, Jahan. And one little detail that I'm going to share that Jahan did not share is that Jahan developed this product in his garage, if I remember correctly. So it was a great contribution by Jahan to both Healthmark, but more importantly, the sterile processing industry at large. This is something that is a true game changer, a very simple, easy to use test for your cord. Guys, if you have not seen it, it's the Healthmark Continuity Tester. I am a little bit kind of being promotional about this right now, but partly that's just because of the nature of this simple device and the amount of risk mitigation involved with this. It's a very easy device to use. Highly recommend it. So please go to hmark.com, reach out to your sales rep, your local Healthmark sales rep, ask about this. You won't be mad for reaching out. You will be satisfied with this. It's a very simple one, easy to use. And anyway, Jahan, thank you so much for contributing to the product line and to patient safety, and also to the podcast. We appreciate you being on here. Look forward to more episodes in the future, probably with you.
Yeah, as always, a great pleasure talking to you both. You always do a great job. Thank you for inviting me. Appreciate it.
All opinions expressed on this show are those of the presenters. Before using any medical device, it is important to review the device manufacturer's instructions for use.